Pre-calculus 4.1 day 2 and an intro start with 4.3. And so we're going to start with arc length of a circle and area of a sector of a circle. But it is important to note that in both of these that theta is measured in radians. These formulas will not work unless the angle is in radians. And so arc length is literally the length, if you would take a string and place it along the circumference of the circle that is indicated and go and measure it, you would get the arc length according to the units that you're measuring it, inches, centimeters, meters, etc. And so for a circle, to get that S, which is the arc length, you take the radius times theta. Again, theta must be in radians. For sector area of a circle, so again, arc length. So if I have a circle and here's your radius and here's theta, this right here, from here to here, is S, which is your arc length. You take a piece of string and put it on the circle right along there and measure it with the same units that the radius is in, that's your arc length. Versus area of a sector of a circle, you take and you have theta and you have a radius. The area is the square units it takes to fill up that piece with the same units that the radius is in. And for this formula to work, theta must be in radians, and it's 1/2 the radius squared times theta. So where theta is measured in radians is an important piece of this. So example 1, circle has a radius of 10 inches. Find the length of the arc length, intercepted by a central angle of 140. And again, we want to see these new formulas used. So we have a circle, and I think here's our 0x axis. If I go straight up, that's your 90 degrees. If I go straight to the left, that's your 180 degrees. I need to go 140 degrees, which is somewhere around here. So here I'm rotating 140 degrees. So the arc length is going to be this length. That's going to be S, is your arc length. And to find that arc length, S is going to be the radius times theta. But theta must be in radians. So in this case, the radius of the circle is 10 inches. But I need to change theta of 140 degrees to radians, and there are pi radians per every 180 degrees. And so that becomes 14 pi over 18 radians, which is 7 pi ninths in terms of that angle for radians. So we're going to take the radius of 10 inches times the angle in radian measures, and that arc length is 70 pi ninths inches exactly. Put that in your calculator. Use the pi symbol in your calculator. Do not just use 3.14. It doesn't have enough decimal places. And to 2 decimal places, check it out. You should be getting rounded to 24.43, and don't forget the units of inches. In part B, find the area of the sector. And so again, if I have the circle, and I think of dividing it where here's the center, sorry, it's kind of sloppy there. I'm still going 140 degrees, but now, while this is 140 degrees, I want the square units, in other words, the square inches, where this radius is 10 inches, that it would take to cover that. And so the area is 1/2 the radius squared times theta, but theta must be in radians. So again, 140 degrees, work shown above is 7 pi ninths in terms of radian value. That's your radian measure for your angle. And so we have 1/2 times the 10 being squared times 7 pi over 9. And so you have 100 times 7, 700 pi over 18, or 350 pi over 9, which would be just fine if you're going to give an exact value with inches squared, but they ask you to round to 2 decimals, so take 350 times pi, use the pi value in your calculator, and it needs to be accurate to 2 decimal places, and area is going to be in inches squared. So those are 2 formulas that you need to know, and you need to be sure that you put theta in radian values to use those. And those are the formulas when asked for arc length and sector area we want you to use, those new formulas using angle in radians. So now we're coming down and we want to revisit SOHCAHTOA for right triangle trig. And so if I have a right triangle, this is 90 degrees, and I choose a reference angle. I'll just use this one right here. Here is a leg, here is a leg, and opposite of the right angle is your hypotenuse. And according to which reference angle you use, the leg that is used to create that angle that is next to it is going to be your adjacent leg. And then this leg that is opposite is going to be your opposite leg. Notice it's not, neither of its endpoints are used in creating the angle. They're not the vertices of the angle. And opposite the right angle is always the hypotenuse. And for SOHCAHTOA, sine is opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. That's what the CAH stands for. So cosine's adjacent over hypotenuse, AH. And tangent is opposite over adjacent. So both sine and cosine in the denominator are the value of the hypotenuse. Sine uses the opposite leg over hypotenuse, cosine uses adjacent over hypotenuse, and then tangent is the opposite over the adjacent, according to what that reference angle is. And then we have the reciprocal trig functions. The reciprocal of sine is cosecant, so notice that it is hypotenuse over opposite. The reciprocal of cosine is hypotenuse over adjacent, and the reciprocal of tangent is your cotangent, which is adjacent over opposite. And I usually kind of indicate sine starts with S while its reciprocal function starts with C. The reciprocal of sine is cosecant. And then cosine starts with a C, but its reciprocal function starts with an S. The reciprocal of cosine is secant. And then tangent and cotangent seem to be a little more obvious, that cotangent is the reciprocal of tangent because they both have tangent in it, but it's cotangent. And so that one seems to be a little bit easier. But the reciprocal of sine starts with S, its reciprocal starts with C, cosecant. The reciprocal of cosine, its reciprocal starts with the letter S, not the same letter. So if that can help you a little bit, that would be great, because you need to know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent, and you need to know that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Those are ones that you just need to know. So example 2, use the triangle below to find the values of the 6 trig functions of theta. So here we're talking about theta being the reference angle. And if theta is the reference angle, what comes off of the right angle are both legs. And the one that helps create the reference angle is the adjacent leg, while the side that neither of its endpoints help create the reference angle is going to be the opposite leg. And opposite the right angle is always, always, always that hypotenuse. So opposite that right angle is always the hypotenuse. Now, so for theta, we want to go ahead and just use sine of theta is going to be the opposite leg, which is 4 all over the hypotenuse. And right here, if we find the hypotenuse, we go 3 squared plus 4 squared equals the hypotenuse squared. A squared plus b squared equals c squared. So we get 9 plus 16 equals that hypotenuse squared, which is 25. And so if you take the square root, that hypotenuse is going to be 5. I'm going to go ahead and change these values because I would like to go ahead and have something that has a radical in it. So I'm going to change these up a little bit, and I'm going to go ahead and change this leg to 3 and the opposite leg to 2. So sine of that angle is opposite our hypotenuse. And so that's going to be 2. And then we're going to do the same thing. 2 squared plus 3 squared equals that hypotenuse squared. A squared plus b squared equals c squared. And we get 4 plus 9 equals the hypotenuse squared, or 13 is that hypotenuse squared. Or the hypotenuse, take the square root, it's going to be the positive, is going to be root 13. So I'm going to write that in there. And so the sine is 2 over root 13, but we want you to rationalize that. We want the denominator to not have a radical. So you multiply by that square root of 13, top and bottom. And so the sine of theta rationalized is going to be 2 root 13 over 13, and that's how we'd want to see it. The cosine of theta is the adjacent over the hypotenuse, and so the adjacent to that angle is 3 over the hypotenuse, which is root 13. Again, don't want a radical in the denominator, so rationalize it. We have 2 root 13 over just plain old 13, and that's going to be, oops, I put 2 there, sorry. 3 times root 13 is 3, so that's going to be 3 root 13 over 13. And then the tangent of theta is opposite over adjacent. And so tangent is going to be 2 over 3. And that doesn't need to be rationalized. And then we're going to come over here, and the reciprocal of sine is cosecant. Cosecant is the hypotenuse over the opposite, which the new values will be 2. That already is rationalized. 2 in the denominator is a rational number, so we don't need to multiply it. There you have it. The reciprocal of cosine, remember cosine starts with a C, its reciprocal is secant, starts with an S, and it's the reverse. It's adjacent, or excuse me, hypotenuse over adjacent. So it's root 13 over 3. And there's your secant. And the reciprocal of tangent is cotangent of theta. And cotangent of theta is adjacent over the opposite. So there you have your 6 trig values of theta. Make sure you rationalize. Now, going and reviewing special right triangles from geometry. Special right triangles we have a 45, 45, 90. And then we also have a 30, 60, 90. They're both right triangles, but one's a 40, 40, 45, 45 for the two acute angles. The other is a 30 degree and 60 degree angle. And there are things to remember. On a 45, 45, 90, the legs are equal in value, and the hypotenuse is √2 times longer than a leg. And so to go from a leg to a hypotenuse, you are multiplying by √2. To go the opposite direction, you need to divide by 2. So sine of 45 degrees. So if I think about this as being my reference angle, this is opposite, this is adjacent, and this is hypotenuse. And sine of 40 degrees is opposite over, sorry, that's not right. Come on. Opposite over hypotenuse. And so it's going to be 1 over √2. So sine of 40 degrees is 1 over √2, but we don't leave it with a radical in the denominator, so we rationalize by multiplying by √2 over √2, and you get √2 over 2. So want the exact value. Sine of 45 degrees never changes. The sine of 45 degrees is √2 over 2, and you want to know that. Cosine of pi force, again, 45 degrees is the same as pi force in radians. And cosine is that adjacent over the hypotenuse. But in this case, the adjacent is 1, the hypotenuse is √2. Again, rationalized by √2 over √2. And as you multiply that, you still get √2 over plain old 2. √2 times √2 is 2. So the cosine of 45 degrees and the cosine of 45 degrees are both √2 over 2. Or in radians, sine of pi force, cosine of pi force are both √2 over 2. Then tangent of 45 degrees, or pi force, is going to be the opposite over adjacent in terms of the legs. And the opposite in this case is 1, the adjacent is 1, and the tangent of 45 degrees, or pi force, is always 1. Those are ones you're going to want to memorize. 30, 60, 90 has a little more to it because you have 3 sides and none of them are the same. Unlike 45, 45, 90, both the legs are the same, so that produces some things a little more unique. But on 30, 60, 90, the hypotenuse is twice the short leg, and the long leg is √3 times larger than the short leg. And so opposite the 30 degrees, the side opposite the smallest angle is the shortest. So the side opposite the 30 degrees is going to be your short leg. And then the side opposite your 60 degrees is going to be your long leg. And then the side opposite your 90-degree angle is always your hypotenuse. Is always your hypotenuse. And so as you are looking at these, and the reason why this is drawn the way it is if you take an equilateral triangle, which of sides of 2, 2, and 2, and drop an altitude, so this is 2. If you drop an altitude, it splits that 60-degree angle, because on an equilateral triangle, all the angles are 60, but it splits that top one to 30 degrees. This bottom will still be 60 degrees. And all sides are 2. When you drop that altitude, it splits that base into 1 and 1. And you could actually do Pythagorean's theorem a squared plus b squared equals c squared. That height squared plus 1 squared equals 2 squared. Work it out, and you will find that that altitude is root 3. But on that 30, 60, 90, opposite the 30 is the short leg. Opposite the 60 degrees is going to be the long leg, and opposite the 90 degrees is always going to be your hypotenuse. And to get from the short leg to the long leg, you multiply by root 3. The long leg is root 3 times the short leg. To get from the short leg to the hypotenuse, you multiply by 2. The hypotenuse is twice the short leg. So we always go via the short leg, just to save ourselves on different things we have to memorize. And so the other thing to remember is pi 6, if you multiply by 180 degrees over pi, you get 180 over 6. 6 goes into 18. That is your 30 degrees. So pi 6, oops, in the wrong spot. Pi 6 is your 30 degrees. Well, for 60 degrees, if you take 60 degrees and convert to radians and multiply by pi over 180 degrees, 6 goes into 180 3 times, and pi thirds is your radian measure for 60 degrees. So for 60 degrees, that is pi thirds. So pi 6 is your 30 degrees, and 60 degrees is your pi thirds. You're taking half a turn and dividing by 6 gets you a smaller angle than taking half a turn and dividing by 3. So 60 degrees is your pi thirds, while 30 degrees is your pi 6. So you need to just know those interchangeably. So when I am looking at sine of pi 6, I'm looking at sine of pi 6. Here is my pi 6. This is my opposite, this is my adjacent leg, and this is my hypotenuse. So my hypotenuse be 2, this is going to be 1, this is going to be root 3. And sine is opposite of our hypotenuse. And so sine of pi 6 is 1/2. Cosine of 30 degrees, which is the same as cosine of pi 6, because cosine is a 30-degree reference. Cosine is adjacent over hypotenuse, so it's going to be root 3 over 2. While tangent of 30 degrees, again, same as tangent of pi 6, is opposite over adjacent, is 1 over root 3. But then we need you to rationalize always and write it times root 3 over root 3 times root 3 over root 3. You get root 3 over 3, and that is your tangent of 30 degrees. So exact values for those, and you should not be using any kind of calculator, graphing utility that are giving you these exact values. You need to get your mind to memorize all of these, where you are not using any kind of reference tool or utility, calculator, Desmos, internet to get these values, because these are things where you, as you move on, you are expected to just know these values. So you're going to do yourself a huge disservice and take too much time on a test to get these values if you are trying to just plug them into things. Please do yourself a favor, memorize these. Now, when we go to sine of 60 degrees, we've changed the reference angle on this. So while this is 60 degrees and this is your 30 degree and this is your right angle right in here. Now this is your reference angle. So this is your adjacent leg. So adjacent, and this is going to be your opposite leg. They switch positions because it's a different acute angle. Now your hypotenuse still stays the same because it's opposite your right angle. Hypotenuse is 2. Opposite your 30 degrees is your short leg. Opposite your 60 degrees is your long leg. And so for the sine of 60, which is opposite over adjacent, but we've changed our reference angle, you get So opposite of, I don't know what I said. Sine is opposite over hypotenuse. If I said that wrong, I'm sorry. But sine is opposite over hypotenuse, and that's going to be then opposite root 3 over 2. And that's your sine of 60. Your cosine of 60 degrees is adjacent over hypotenuse, which is going to be 1/2. And your tangent of pi thirds, remember tangent of pi thirds is the same as taking 180 divided by 3, divide it into equal thirds at 60 degrees. And so we're still using a 60-degree reference angle, and tangent is opposite over adjacent, which is your root 3 over 1, which we are just going to write root 3. And so that is how you should be able to find the sine, cosine, and tangents of 45, 30, and 60 degrees by simply using a 45 degree triangle where you let the legs be 1 and the hypotenuse root 2, and by using a 30, 60, 90 degree triangle where the hypotenuse is 2, short leg is 1, and long leg is root 3, and changing which reference angle you're using, 30 degrees, 60 degrees, which changes your opposite and adjacent sides. You should be able to just develop those, no electronics used, and I cannot emphasize enough how important that is to be able to do those. Now, you're going to, in your homework, be given a value of one of the 6 trig functions. And so here, you have sine of theta is 0.6. And so you need to realize sine of theta is defined to be the opposite leg over the hypotenuse in a right triangle. And so you need to think the opposite leg is 0.6, and if I write that over 1, I have a ratio of the opposite leg to the hypotenuse. So then theta is an acute angle and of a right triangle, so set up a right triangle where you choose one of the angles. I don't care if it's realistic so much or not, but just you write a right triangle, you designate your reference angle, and I want to use this ratio. 0.6 is your opposite and 1 is your hypotenuse. So if this is my reference angle, is this theta, then the opposite leg is 0.6 while the hypotenuse is 1. And then I can find the third side of this by a squared plus b squared equals c squared. And so it doesn't matter which one's which, but 0.6 squared plus b squared equals 1 squared, because c is always your hypotenuse. And you get 0.36 plus b squared equals 1, or b squared equals 0.64. And it's plus or minus, but it's a triangle. So b is going to be, take the square root of that, 0.8. So now I know that's 0.8. So this is your opposite, this is your adjacent, and this is your hypotenuse. And so now find the values of cosine and tangent. So for A, cosine of theta, I know that's adjacent over hypotenuse. And so that would be 0.8 over 1, and the cosine of theta is 0.8. Find the tangent. Well, tangent is opposite over adjacent. So opposite is 0.6, adjacent is 0.8. Do not leave them with decimals. Multiply by 10 top and bottom. We'll keep it the same and reduce, and we have the tangent is 3/4. Now, there is another way to do this. 0.6 is 6/10, which is 3/5. And so I could create the triangle where sine of theta is 3/5 and use integers, which might feel more comfortable. And since sine is opposite over hypotenuse, if this is my reference angle, the opposite leg is 3, the hypotenuse is 5, and to find this other side, I could use 3 squared plus b squared equals 5 squared, and I get 9 plus b squared equals 25, or b squared equals 16, and b is 4. And figure out this side is 4. So this is adjacent, this is opposite, and this is your hypotenuse. And then I could do cosine of theta is adjacent over hypotenuse. And that would give me 4/5, which is the same as 0.8. And for part B, the tangent of theta is opposite over adjacent, which would be 3/4, which is exactly the same as I had before. And this might be the preferred method, is to change that 0.6 to an integer over an integer by making it 3/5 and setting up the triangle that way. Show work on these. Don't have just answers.